Hi, welcome to today's class. We are going to talk about the JavaScript prototypes. So maybe when you are going through the documentations, especially on arrays, you would find something called array.prototype dot let's say filter or anything in fact. So we are today going to explore what that prototype means and how we can try to start to use that also. Right. So let's try to first understand how we right now use objects. Right. So the easiest way we would create an object, let's say a person object, is to create an empty object here, and we would give it a name by using person.name, and we'll just give it something like this. We'll define the name as J. And let's say we want to give it some energy for that particular person. We can define it by saying this. Let's assume we need to give this person object some properties. Like you want to give it like some life properties. Like let's assume that you want to give it um, uh, like you want to say the person can eat, the person can sleep, and let's say the person can code also. All right. So at this point, we can use we can create assign a function to each of them. And we can give it some value into it. And here, let's assume we want to say this dot name, and we can say is, and depending on what the item is, for example, we can say eating, if sleeping, or if the person is coding. And let's say at each of the positions where we need to reduce the energy or increase the energy. So for eating, your energy increases. So you can say this dot energy uh, increases by some amount, which we state. And let's say we can increase some energy here. So this dot energy plus equal to, let's say, the time. And while coding, your energy reduces. Now, this doesn't make sense when we have to write this every time for a person object, right? So this is when we would generally use a constructor for this. So we can wrap this entire thing in a person constructor, which takes a name and an initial energy. And or we can wrap everything inside that, and at the end of it we will return person. All right, so let's create a couple of people from this. Now instead of J, we are going to call it name, and we can call it energy here. And let's say we want to create two people from this. So let's call it Sai, and let's give him some 15 as the energy. Give J, give him 12. Now, if we were to see Sai and J, yeah, let's run this program. You can see that it has these properties on it: eat, sleep, and code. So let's actually invoke each of this, and we'll say j dot sleep is 5, and let's run this program again. You can see that Sai, you can get the output saying that Sai is coding and J is sleeping. So now we have been able to move everything inside a single constructor, and we are able to reuse these functions a lot. This is simple and it works, but if you think about it, that this particular function is being created again and again. And you can see that these functions are quite general in nature, that Psi and J use a similar functions, and it is being used, like it's a term called redundancy. It is being used again and again. For every instance of the person object which is being created, we are having the function inside the object that we create. So if you go to console log of Psi, and if you make J and you run this, you can see that this eat, sleep code is a part of it. So this takes up extra space in your program. So this is sometimes not desirable as such, because this takes extra space and memory. So one way we can do this is to have an object where we can create all the methods and store it there. All right, so let's remove all of this here, and let's yeah. Yeah, let's write this here, and let's finally make it for the code also. And what we can do here is that we can write person.eat is equal to person methods dot eat, and person dot sleep is equal to person methods dot sleep, and finally we can write person dot code is equal to person methods dot code, and it returns the person object. Now if you were to run this again, we would get a similar output, but you can still see here that the methods are still being stored in there, even though we have kind of made it a little more cleaner, but it doesn't really solve the problem as such. So objects come with a function or a method called object.create. It allows you to create an object using an existing object. All right. So what it essentially does is that when you initially create your person, what you can write is you can write object.create, and you can pass in person methods. And now if you were to run this, you can see that you are still getting the output correct. You are getting size coding, J is sleeping, but you can see that inside your object, you're only seeing the name and energy. So what object.create essentially does is it creates this as a parent object. We'll just comment everything for now, and I'll just show you another example of what uh, it does. So let's assume we have a parent object. Let's call it parent. Give it age is 40, and let's say country as India. Now, if you were to create a child, and we say object.create from this parent, and now you were to give child.name is child and child.age is 10, and now if you were to just see the details of child, you would get name is child and the age is 10. But if you were to write child.country, we would get India as the output. This is because it has country on its parent. We are overriding child.name and age here, and it creates it locally onto the child's objects, but it still has the country on it. Even though it's not being seen here, it is because it is being stored in the parent object. So it is, you can think of it as inheriting some properties. So your country, your heritage, etc. are being inherited from a parent. So you're essentially inheriting some properties from the parent object. Even though it's not being seen here, you are referencing it. So what essentially happens when you write child.country is that it searches inside your child object if the country key exists. If it does not exist, it checks in the parent object. And when it finds in the parent object, it gives that output. So now we know what object.create does. Let's go back to our example. And we can see that now how we have made this eat, sleep, and code onto your parent object. So it is inheriting some properties from the parent person methods. So this seems well and good, but JavaScript already has an inbuilt methodology or a process to handle this for you. And that is called the prototype or prototypal inheritance. So how we can do that is, let's remove this now. And we can write this as each of the function that we write here can be written as person.prototype.eat. So let's write that for everyone. Person.prototype.sleep or eat. So we'll make changes here. All right, so we made those changes, and instead of object.create person methods, we will pass in person.prototype. Now we can see that it gives you the same output. Let's, yeah, you can see that it gives you the same output that it creates from this person.prototype.eat. Now, we know that we use constructors with the new keyword, right? So what new keyword does is that it references with this object. So let's change this to this, and we can get rid of this object.create and reference the person.prototype. So the new keyword does this for you. It takes the person.prototype methods and creates this as a parent for you. Now, if you write this, you would still get the same output. So you don't have to write object.create every time. You only have to write the prototype methods here. So we have right now used prototype. We understand a bit of how inheritance work in objects. And in our next example, we are going to look at how we can create your own arrays. So we have seen that in arrays, everything comes with a prototype method, right? So we'll try to create our own array after this. And now, why is the prototype method important? Again, just to iterate, is that let's assume we make 100 or 200 of these items. Each and every object that you create can access this prototype method. And you don't have to recreate this particular function every time. There is only one of these existing in the prototype, and everyone will have access to it. Now, let's just try to visualize that also before we end the discussion. So let's assume you have n number of objects, right? Now, rather than having this object written, every one of them having their own functions to handle it, instead of that, we have this prototype functions where each and every one of the objects here can access the prototype methods. So you can see how it reduces the space required or the memory required. So whenever you write sci.code or sci.sleep, it searches within this object if it exists. If it doesn't exist, it will go to the parent. Now you can have multiple levels of parents also. So you would search in the next parent also if there exists. So when you do more complicated objects, you can actually create more levels of inheritance. But as of now, you don't need to worry about that. Let's look at only one level of inheritance. All right, so we'll meet again for the next session regarding how to create your own arrays.